So on exercise number 3 in more iterations, they ask you to create a function that takes in a number and then returns true if that number is prime and returns false if that number is not prime. So this is kind of a classic computer science program, and it's just one of those things that you might just be banging your head against the wall trying to figure out, but once you see it, you kind of never forget how it works. So let's go ahead and discuss what a prime number is. Right, a prime number is a number that is divisible only by 1 and itself only. Right, so every number is divisible by 1 in itself, but not every number is only divisible by 1 in itself. So let's take the number 7, and we are going to put 1 and 7 here. It's definitely divisible by 1 and 7 because all numbers are divisible by 1 in itself. What we need to do is check if 2, 3, 4, 5, or 6 are evenly divisible into 7. Right? So how does that work? Well, we need to make a function first of all. So we're going to say like is prime. We're going to take in an argument, right? So we're going to say pp for possible prime. And then in the possible prime, the numbers that we need to check are not 1 or 7, right? Those are known. We need to check from 2 up to pp minus 1, right? So in order to do that, we need to have a for loop. That's where the iterating variable is going to be equal to 2. The first iteration is going to be equal to 3, then 4, 5, and 6, and then it's going to break. So we can say for I in range, and we could say 2 comma pp, right? So the first iteration of this for loop, I is going to equal to 2, then 3, then 4, then 5, then 6, and then when I increments to 7, 7 is not less than 7, so it's going to break, right? So this for loop is going to do what we want it to do. And now for every number of I, every incarnation of I, we need to test, is it evenly divisible into pp, right? So how do we do that? Well, to test for anything, to check for anything, it's always an if statement. So we're going to say if, right? And we could do pp divided by I, which is 2, and that would give us the number 3, right? But that wouldn't tell us if it's evenly divisible into 7. What would tell us if it's evenly divisible into 7 is using the modulo operator. Right. Modulo, if you remember, returns the remainder of a division operation. So 7 mod 5 would return 2, right? Because 5 goes into 7 once and leaves the remainder of 2. Let's say 12 mod 10 would return 2 as well, because 10 goes into 12 once and leaves a remainder of 2. Right. So here we're going to do pp, which is our 7, right? Pp mod I, which is 2 during the first iteration of this for loop. And if that remainder is equal to 0, then what do we know? We know that I is evenly divisible into pp, into 7. And if that's true, what do we need to do? We need to return false, right? 7 pp is not prime, right? Return false, right? So this for loop is going to roll, it's going to iterate, and it's going to 7 mod 2, that's not going to be true. It's going to do 3 mod 7 mod 3, that's not going to be true. 4 mod 3, it's not going to be true. 5 mod 3, 6 mod 3, it's not going to be true. None of them are going to be true. And when this for loop ends its iteration, and if it never returns false, then what do we know? We know that it is prime, right? Because none of these numbers from 2 up to pp minus 1 were evenly divisible into pp, into 7. So what we can do here is we can return true, right? Yeah, so that's the is prime function. And just one thing to note is that checking if a number is prime is a very time-consuming process, right? Because you need to check a lot of numbers, and there's a lot of math calculations going on, right? If you have a number that's 32 digits long, you need to have a for loop that's going to iterate through all of the numbers from 2 up to that 32-digit number, right? So that takes a long time. So that's why encryption is based on prime numbers, very large prime numbers, and Bitcoin is also based on very large prime numbers, because in order to break the encryption, it would take longer than the age of the universe, longer than the continued age of the universe to solve using current technology.